Well, dear my students, I hope you have seen last video of simple eye motion and enjoyed the topic taught by me. Simple eye motion, I told you, has three characteristics. Motion takes place to and fro in a straight line about fixed point, and acceleration of motion proportional to displacement. Simple eye motion, it is periodic, number one. Number two, takes place, repeat itself in straight line to and fro about fixed point. And number three, the acceleration of motion proportional to displacement. Now we will study some motions and will prove them that the motion of these bodies are simple harmonic, and will try to find out time period. So a simple pendulum simply consists of a heavy bob tied to a massless inextensible string. Massless means mass of string negligible small in comparison to mass of bob. This is called bob here. Bob, B-O-B, bob. Now, it is in vertical position, it is in equilibrium position. When this bob is here, the mass mg act downward, weight mg, and tension T upward. In equilibrium condition, it remains vertical, net force 0, tension T and mg balance each other. But now if we gently displace it, so it oscillates to and fro. So we have to see that at an instant it is at this position. Bob is here, and it makes theta from vertical position. Let effective length be L. Total length of this. Here theta, weight still act downward. Weight mg still act vertically downward. Actually, length of arrow gives the magnitude. These arrows should be of equal when we are drawing the diagram. I have told you a vector is represented by a line with an arrow. The length of line represents magnitude. Then remaining the other force is tension T in the string. If we produce this angle theta, and we can resolve mg into two components. Here this is perpendicular, so this one is mg cos theta, and other one here mg sin theta, this one mg sin theta. I hope you know how to resolve a vector into components. I am writing it here, mg sin theta. This component here is mg sin theta. mg cos theta and mg sin theta are the component of weight of the bob. So in figure, this is O point, this is point P. In figure, a simple pendulum is in simple pendulum, of effective length L. You may ask, what is effective length? Actual length of the string plus radius give effective length. Different length L and mass of bob M is suspended from a rigid base. When it is gently displaced from equilibrium position, O, then pendulum oscillates about equilibrium position O. O. So this oscillate to and fro about this position. Now let at any time both is at point P. The angular displacement in this position is shown as theta, while linear displacement x, while linear displacement equal to x. At point P, forces acting on both are: number one, weight mg of the bow; number two, tension capital T of spring. Here we can resolve weight mg into two reactant components. Here weight of bow mg can be resolved into two rectangular components. Dear student, components, you must remember rectangular components which are perpendicular to each other. I am showing you for understanding. If it is vector r, it is theta, so this much component is r cos magnitude, r cos theta. Vector r, the magnitude of this component. Here it is r sin theta. You can show it here. Rectangular component means the component of vector which are perpendicular to each other. तो ये परपेंडिकुलर है, रेडियस पर टेंजेंट into two components in figure mg cos theta x opposite to tension T and mg sin theta towards equilibrium position O. mg cos theta बैलेंस या इज बैलेंस की इज बैलेंस्ड बाय टेंशन टी वाई एम जी साइन थीटा remains unbalanced. Since mg sin theta unbalanced and act toward equilibrium position, so mg sin theta acts as restoring force. A child may think, what is restoring force? The force which always try to restore the equilibrium position. So certainly it will be acting toward equilibrium position opposite displacement x, and hence we write F equal to minus mg sin theta. Minus sign indicates that this force is opposite to displacement x, but displacement always measured from equilibrium position, and force act opposite to this. Or we can write this F by m minus g sin theta. G sin theta. From Newton's second law of motion, from जो कहाँ से हम कहाँ जाना पड़ता है, from Newton's second law of motion, F by m equal to acceleration. Let it be alpha. A I don't write because I have used A as amplitude here. So alpha equal to minus g sin theta. Acceleration. तो characteristic देखो, वैसे तो हम in case of simple motion we can say the motion in which force always act toward equilibrium position, which as restoring force, but I have taken there the motion has acceleration which is towards equilibrium position. G is acceleration due to gravity. Alpha is the acceleration of motion of the ball. And I have told many times that acceleration is the change in velocity per unit time. Now here again there is something which troubles the student. If theta is small, if theta is small, that is theta tending to 0. देखो स्मॉल वेरी स्मॉल एक ही बात है. हमने कह दिया लेंथ नेग्लिजिबल स्मॉल तो स्मॉल, लेंथ स्मॉल तो भी स्मॉल है, मास लेस तो मास तो है लेकिन वो नेग्लिजिबल है. So when theta is very small, then I have told you in one video, if theta tends to 0, then sin theta is equal to theta. Here trouble lies that if it is 10 degree, then it is not 10. Actually theta should be used here in radian. And I have told you that 1 degree equal to 0.10174 radian. If it is 10 degree, it comes 0.174. If you see the log table, sin 10 is equal to 0.174. So theta is very small, and from definition of angle equal to arc upon radius. This is arc, this is radius L. So it is equal to x by L. I have seen student get in puzzle here. How it is sin 1 to 1 नहीं होता. Sin 1 degree का मतलब है 0.0174 और sin 1 डिग्री की वैल्यू जो है वो यही आती है. और दिस एप्रोक्सीमेशन थ्रू अप टू 10 degree. I have seen in books telling the so many things, but unable to tell this case. Here I am replacing radian. So from equation 1 we get, hence from equation 1, alpha equal to minus g x upon L. x upon L. x क्या है? Displacement from given position. L length. और alpha equal to minus g by L. Alpha means g upon L into x. I am telling again, alpha is the acceleration of the motion of bow. X displacement, g action to gravity remain constant at one place, and L length. Here g upon L is a constant value for a given pendulum. At a given place. So alpha proportional to minus x. Acceleration proportional to displacement minus sign indicate opposite, and hence motion is simple harmonic. Motion is simple harmonic. It may happen with you that you are not able to understand in first instance. Repeat 2 times or 3 times and think on what is being told to you. Compare the situations. Now the equation for SHM alpha equal to, if we compare this and this, so what do we get? Omega square equal to g by L, or omega equal to under root g by L. And we know if capital T is the time period, then capital T is equal to 2 pi upon omega, or T is equal to 2 pi upon under root g by L, or it is 2 pi under root L upon T. For a given pendulum of length L, time period T equal to 2 L upon G. So time period pendulum depend on length and G only for a given place. If we increase the amplitude, then no effect. If we increase the mass, no effect. If we change the place, G will change. If we increase length, time period will increase. There are many factors I will be discussing later on also. But please try to learn this. Thank you.